All right, I have a problem here. Jacob and Emily ride a Ferris wheel at a carnival in Billings, Montana. The wheel has a 16-meter diameter. So let me draw the wheel. It has a 16-meter diameter. Let me draw it big so we have a lot of space. So it has a 16-meter diameter. So what's its radius going to be? Its radius is going to be half of that, right? So if I were to draw its radius, just draw it like that. Its radius, it's a 16-meter diameter, so its radius is going to be 8 meters. With its lowest point above the ground, with its lowest point 1 meter above the ground. So its lowest point is right here. This is its lowest point. And that is 1 meter above the ground. So this distance right here is 1 meter. Fair enough. Assume that Jacob and Emily's height h above the ground is a sinusoidal function of time where t equals 0 represents the lowest point on the wheel. So this is at point t equals 0, right here. T equals 0, the lowest point of the wheel. Write an equation for h. Oh, I think I forgot. So let me reread it. Jacob and Emily ride a Ferris wheel at a carnival in Billings, Montana. The wheel has a 16-meter diameter. We did that. And turns at 3 revolutions per minute. So it turns at 3 revolutions per minute. 3 revolutions per minute. With its lowest point 1 meter above the ground, assume that Jacob and Emily's height h above the ground is a sinusoidal function of time, where t equals 0. So we need to write a function of h, their distance above the ground, as a function of time. And they're saying that time is given in seconds. So first of all, they're telling us 3 revolutions every minute, right? So that's 3 revolutions per 60 seconds. And that's the same thing as 1 revolution per 20 seconds, right? I just divide kind of both sides of the per by 3 per 20 seconds. And 1 revolution is how many degrees? 1 revolution is 360 degrees. So it's 360 degrees per 20 seconds. And if you're going 360 degrees per 20 seconds, let's divide, the per, you can just kind of use this as an equals sign or an equation. What's 360 degrees per 20 seconds? That means you're going to go, what, 18 degrees. Just divide both sides by 20. 18 degrees per second. 18 degrees per second. I mean, we could have done this with a numerator and denominator. 3 revs per, you could have said 3 revs over 60 seconds. That's actually how I should have done it. 3 revs over 60 seconds is equal to 1 rev over 20 seconds, which is equal to 360 degrees over 20 seconds, which is equal to 18 degrees, that's degrees, per second, right? So we're going to travel 18 degrees per second. So the total number of degrees we've traveled in t seconds is going to be, so see, if we say the angle, that's the angle from our starting point. So let's say we've traveled t seconds and we're right there. Let's drop a little altitude right here. What is this angle going to be? Where this angle is right here. What is this angle going to be? How many degrees have we traveled? Well, we say we traveled 18 degrees per second. So if we travel t seconds, this is going to be 18 t degrees, right? All right. So let's see if we can figure out how their height as a function of this, well, as a function of t, or as a function of this angle right here. So at what is this height right here, up here? It's 1 meter plus the radius, because this distance right here is 8. So we could say that this point right here is h is equal to 9 at this point, right? We could almost view that as the h-axis, but so that's h is equal to 9. So at this point, how high are they? If this is h, so right now let me draw a little drop, go flat here. So we want to say their height above the ground. So their height above the ground is this distance, h, which is the same thing as this distance, h. So what is that distance? Well, it's going to be, well, if this distance is h, what is this distance going to be? this distance is going to be 9 minus h. How do I know this? This whole distance is 9. This distance is h. So let me do it in a better color. So that this distance right here is 9 minus h. So let's see what we can do. What do we know? We know this distance. We know this angle is 18t degrees. And do we know this side? Sure, that's the radius. That's 8 meters. 9 minus h meters, 8 meters, and 18 degrees. And what are these sides relative to this angle? Well, if we were to draw this, if we draw a right triangle here, and we relative to this angle right here, the 9 minus h is adjacent, and the 8 meters is, of course, the hypotenuse, right? So we could say, so what trig function deals with adjacent and hypotenuse? So toa, cosine is adjacent over hypotenuse. So we could say the cosine of 18 degrees, the cosine of 18t degrees, 18t degrees is equal to its adjacent side. The adjacent side is 9 minus h, is equal to 9 minus h over the hypotenuse, over 8. And now we can solve for h, and we'll have h as a function of t. So if you multiply both sides by 8, you get 8 cosine of 18t is equal to 9 minus h. Maybe we could subtract 9 from both sides. So we get minus 9 plus 8 cosine of 18t is equal to minus h. And then multiply both sides by negative 1. And then you get 9, positive 9, right? Minus 8 cosine of 18t is equal to h. Or h is equal to 9 minus 8 cosine of 18t. So there we have it. We have expressed h as a function of t. And in the next video, I'm actually going to graph this function. See you soon.